Okay, here we go. So we're solving equations using logs. Solving equations using logs. So earlier in this unit, oh, the screen is frozen, sorry. Earlier in this unit, we used the method of common bases, right? We make sure that we have the same base, a power of 2, a power of 3, whatever, to solve exponential equations. This technique is quite limited, however, because it requires that two sides of the equation be expressed using the same base, right? So a more generalized method is needed. And we have one. It's called the third logarithm law. So here's what it says. So I want you to really pay close attention to what we're doing. I'm going to make this nice and big. So it says log base b of a to the power of x equals x times log base b of a. Do you see what I did to the exponent? Everybody watch. Boop. I just moved it to the front. Do you see that? Okay. So we're going to solve this problem right here. 4x equals 8 using the common bases method. And then we are going to use the common log method. So common bases, let's see. 4 is the same thing as what? 2 squared. So I have replaced the 4 with 2 squared, but it's still to the power of x. 8 is the same thing as 2 to what power? Okay. So I know that I distribute these two. And because I have the same base, what do I know is going to happen to my bases? They drop, right? Do you guys remember that? So this becomes 2 to the power of 2x equals 2 cubed. Drop your bases. 2x equals 3. Divide both sides by 2. And it means that x is 3 halves. Or 1.5 if that's how your brain works. But okay. So this is where you're going to need your calculator. So now we're going to use the logarithm approach. Now we're going to use the logarithm approach. Here, I'm giving you my copy. What's your question? Because, yeah, remember you can drop those bases, right? Okay. So the logarithm approach. So we take some exponential function, so we write it as log, God bless you, 4 to the power of x equals log of 8. That's how we write it. So now what do I do with this exponent? Move it to the front. So I really have x log 4 equals log 8. I am trying to get x all by itself. That's all I'm trying to do. So what do I have to move away from x? Log 4. And this is all smushed together. It's a product. So this is a product. So if I want to move it away, I have to divide by log 4. I have to divide both sides by log 4. So x equals log 8 divided by log 4. There is no base, log of, like log base whatever, because this is the base 10, right? So we want to find out what x equals. So grab your calculator. And you're going to use your log button that's right here on your calculator. Everybody look. And you're going to type in log 8 divided by log 4. Zach, are you with me? It looks like you're sleeping. Okay. Log 8 divided by log 4. We're not using the math button. Any weird bases? What do we get? Say it. 1 point what? Okay. Let me turn my calculator on. Log 8 divided by log 4. I get exactly 1.5.
I do.
Okay. So where are you? Okay, you have to close your parentheses, guys. No, it doesn't do it for you. Close your parentheses. Divided by. Yeah, you gotta close the parenthesis, otherwise it's taking a log of a log. Log 8, close your parenthesis, divided by log 4. Close your parentheses, enter. Okay, did everybody get 1.5? Did you try this? Did you try this? Okay, you need to try it. Okay, are we good? Who did not get that? Manuel, what'd you get? I'm coming to look. You have that look on your face. Divided by log 4.
He wasn't divided.
Okay. Okay, so listen, log 8. No, you're not listening. See, this is why I get frustrated. So I said, I held this up. You have to use this button, the log button. Okay? So clear all that out. Log 8, close your parenthesis, divided by log 4, close your parenthesis. You gotta stay with me. We're not doing bases because it's base 10. Shh, this is the common log. All right, moving on. Shh. So the beauty of this logarithm is that it removes the variable from the exponent. This law in combination with logarithm base 10, the common log, allows us to solve almost any exponential equation using a calculator. So let's practice it again. So log 5 to the power of x equals log 18. What do we do with that exponent? Doop. Put it in front. So x times log 5 equals log 18. Trying to get x all by itself. Yes, we're going to divide both sides by the log of 5. So your calculator, this is like your calculator, dude, right? What are you putting in there? You're going to type log 18, close your parenthesis, divided by log 5, close your parenthesis, and hit equals. You have to do that. I got 1.80, it's about 1.80, right? Because it's to the nearest hundredth, so it's about 1.80, correct? Yeah. Okay. If you didn't get that on your calculator, raise your hand so we can help you. Okay. You have to know how to do this.
Oh, I see what I did.
Oh, what did you do?
I put 15 instead of 18.
Perfect. Okay. Next one. Who can tell me how to set this one up? Yeah, I was hoping that someone would see that. Let's just move the x to the front right now. So x log 4 equals log 100. So we're dividing both sides by log 4. Log 4. So x equals something in our calculator. We're doing log parenthesis 100, close your parenthesis, divided by log parenthesis 4. Okay? I did close my parentheses. They're not pretty, but it'll work. So what are we thinking? What did we get? 3, 1, what? Well, yeah, 3.3219. So if we're doing it to the nearest hundredth, we're going to leave it as 3.32. Right? Yes. Set up C. Anyone? Go ahead, Max. Yeah, tell me you guys don't love this. So we're dividing both sides by log 2. Dividing both sides by log 2. So x equals what? Yeah. So what's the matter? Do you already have those all filled out? You did. I'm sorry. Okay. So you understand the system, right? A little bit? Okay. So sometimes they might be a little bit more complicated, but each and every time you'll be able to use the log law. So let's look at this one. 6 to the power of x plus 3 equals 50. So remember, this is your exponent, right? So we're just going to move it out front. And I'm going to put it in a parenthesis because it's that whole thing is my exponent. Does that make sense? So I have log 6 equals log 50. What do you want to divide both sides by? Yeah, log of 6. So I get x plus 3, because this cancels out, equals, and I wrote mine as, well, I don't know what I wrote mine as because I gave my, 2.183. That's what I wrote that as, 2.183 when I divided. I carried it out like 4 decimals. Did you guys get something like that? Log 50 divided by log 6? Something like this? You're subtracting. You're subtracting, right? So x equals about a negative 0.82. Okay, it's negative. 2.18 minus 3 is negative 0.82. Zach, are you awake? Get your hand off your face. Okay, are we ready for the next one? Okay, what's the exponent? Say it. So x divided by 2 minus 5 comes out front. And that's the same thing as saying half of x, right? You guys see that? So I have to write the log of 1.03 equals log of 2. So I'm dividing both sides by log of 1.03. Dividing both sides by log of 1.03. And when I do that, I get 1/2 x minus 5 equals, give me 3 decimals on this. What is the log? Log 2 divided by log 1.03. Log 2 divided by log, anyone? Here, I'll just do it since we're all being real quiet and we can't talk today. I just want to know what log 2 divided by log 1.03 is. 23.4. I want 3 decimals. 4 what? 50. Did you round? No, just give me 3 decimals. No rounding. Just 449. Thank you. So 23.449. I love that. Okay. So we have to add 5 to both sides, right? Because we're trying to get x all by itself. So that tells me that 1/2 x equals 28.449. And then we multiply both sides by 2. So x equals 56 point, I think, I can't get rid of that big old honkin' 0 there. What is going on? Oh, we're fighting. Okay. How are we doing? I think the notes that were posted weren't my notes. They're like are they like the standard notes or whatever?
I don't know, they were in like a box.
Yeah, does it make more sense the way that I'm like moving stuff over? Because my work is a little bit different than yours.
Yeah, kind of.
Okay, you do whatever you need.
I think the way that I did it was kind
Okay. All right. Reese, you see you have filled out notes right there. Okay. All right. So we're going to talk about increasing exponential functions. Now that we are familiar with this method, we can revisit some of our exponential models from earlier in the unit, like exponential growth and decay. Recall that for an exponential function that is growing, we do 1 plus the rate to the power of time. Zach, come and stand by me. So if Q is known to increase by a fixed percentage in decimal form, then Q can be modeled by Q of t, which is just like a function of time. Stand right there, don't sit down. Q sub 0, that just means at the very beginning when time is 0, that's the initial amount. And then 1 plus p, your decimal or your percentage written as a decimal, you should recognize that. So we're basically just using the exponential growth and decay formula, okay? So here's what we have. A biologist is modeling the population of bats on a tropical island. When he first starts observing, there are 108 bats. This is the initial amount. This is my Q of 0. It's the initial amount. The biologist believes that the bat population is growing at a rate of 3%. That's the same thing as 0.03. Is everybody good with that? Okay, so it says write an equation for the number of bats. The number of bats is a function over time. That's why it's written as B of t equals, well, let's say we take the initial value, which is 104 bats, times the quantity 1 plus 0.03 to the power of t. And I'm going to go one step further and just simplify that parenthesis, because 1 plus 0.03 is the same thing as 1.03. Okay? Does that make sense? Does everyone see what we did there? Okay. Using your equation from part A, algebraically determine the number of years it will take for that bat population to reach 200. I could not fit this in the little box that they gave me because I write way too big. Sorry, Reese, I know those are messy. So it's just saying you want your total population to be 200. Well, that's your B of t. So 200 equals, what was our initial value? 104 times 1.03 to the power of t. Well, we know that if I have something equals an exponential function, we can solve it. So we just need to get this piece all by itself. Well, the only way to do that is to divide both sides by 104. That's the first thing I'm going to do, divide both sides by 104. Okay? Michael, you with me? Okay. So I have 200 divided by 104 equals 1.03 to the power of t. Now I'm going to use the log method. Log 200 divided by log 104 equals t times log 103. Right? Because I took this exponent and I moved it out front. So I'm trying to figure out how much time this is going to take. So I'm trying to solve for t. So the only way to do that, I'm going to kind of smush this up here. I'm going to rewrite this really fast. Log 200 over log 104 equals t times log 103. So I have to divide this by log 103, which means I have to divide this by log 103. Hang on, we can do this. You can do this. You can do this. So here's what I want you to do. Oh, thank you. It should be 1.03. That's just me being crazy. 1.03, 1.03, 1.03, 1.03. Thank you. Okay, so make sure you can see your decimal in there, guys. Sorry. It's because I don't have my filled out notes. I'm just wanging it. Okay, so here's how you're going to put this in your calculator. Use a great big parenthesis. Okay, so I want you to type in log 200 divided by log 104. And I know you have to put parentheses after those little guys. And then close your big parenthesis. And hit divided by log 1.03. So I'm going to use a great big parenthesis first before I even press the log button. Great big parenthesis. Log. Just touch the parenthesis before you touch anything else. It just is big because it's first. Log 200, close your parenthesis, divided by log, yeah, 104, thank you, I couldn't even read my own writing. Close your parenthesis, divided by log 1.03. Close your parenthesis and hit enter. Alrighty. What did you get? That is not right. What did you get? Yeah, we should have taken this fraction first. Reese, can I look at my notes for a second? What is 200 divided by 104? What is it? So let's do the log of 1.923. That's all right, I got it. Sorry, guys. So I'm going to rewrite this as log of 1.923 divided by log of 1.03 equals t. Tell me what you get there. Because we should get, I thought it was only like 23. Okay, there you go. T equals 22.1 something years. Is that what you got originally? Sorry, I suck. Okay. All right, a stock has been declining. Decay. Declining is decay, so we do 1 minus instead of 1 plus. Got it? At a steady pace of 5% per week, if the price started at $22.50, so that's my initial value, 22.50 times 1 minus 0.05 t. How long, how many weeks, t is our number of weeks, will it take for the price to reach $10? Okay. Well, let's first of all simplify this little guy right here. So 10 equals 22.50 times 0.95, right? Mm-hmm. Then I would divide both sides by 22.50. Divide both sides by 22.50. And tell me what you get as a decimal. Let's do 3 decimal places. Divided by 22.50. Oh yeah, that's nice. So 0.444. We're just going to leave it like that. Equals 0.95 to the power of t. So now we're going to use the log. So log of 0.444 equals t times the log of 0.95. We're going to divide both sides by the log of 0.95. Divide both sides by a log of 0.95. We find out that t equals, let's see, log 0.44 divided by log 0.95. So I get about 15.82 weeks, or 83 weeks. So if we're doing to the nearest week, it's going to be 16 weeks. Did everybody get that on their calculator? Okay. All right. As a final discussion, we're going to return to evaluating logarithms using our calculator. Many modern calculators find the logarithm of any base. You guys already know that. You hit the math button and you go all the way down to the capital A where it says log. Then you can use the base. Do you guys know what I'm talking about? So let's look at this example. 4 times 2 to the power of x minus 3 equals 17. Well, the first thing that we want to do is add 3 to both sides. Okay. So this says 4 times 2 to the power of x equals 20. Next, we're going to divide both sides by 4. I'm going to kind of bring my work up here. So 2 to the power of x equals 5. This is the same thing as saying log base 2 of 5 equals x. That's what we're trying to find. We're trying to find that exponent. So in your calculator, hit your math button and scroll all the way down to that capital A where you have the log base. And you're going to type in log base 2 of 5 and hit equals. And you should find out hopefully that x is about 2 point, what does it say we have to round to?
321.
Yeah. Yeah, I'm just going to write it just like that. 2.321. Okay, let's do the next one. Okay, so we're trying to get the power all by itself, right? We have to get this guy all by itself. So the first thing that we're going to do is divide both sides by 17. So 5 to the 1/3 x power, maybe it'll help you to see it like that, equals, I'm going to just leave it as 4/17. So now I have to divide both sides by, what does this tell me? What do I do with this? We're going to bring it out front. So 1/3 x times log of, are we solving this with common logs? No, we're not, sorry. We've done too many problems. I wanted to solve it with common logs, sorry. We divided by 17, okay, yeah. So 1/3 is the same thing as x over 3. So log base 5 of the equals, which is 4 divided by 17 equals 1/3 of x. How do I get rid of this 1/3 in front of my x? By what? Multiply by 3. Whatever I do on one side, I have to do on the other. So 3 times log base 5 of 4 divided by 17 equals x. So your log base button, math, log base, blah, 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 blah. 5 of 4 divided by 17. So what did we get? I'll tell you what I got. I got x equals negative 2.697. Did anybody else get that? Okay.